Hello students, welcome to Anne's classes. Let's do rational numbers, chapter 1, test yourself. The test yourself is found on page number 29 in the new book, and we have the multiple choice type as question 1. Choose the correct answer from the options given below. So the question here is 0 by 5 is a rational number, 0 by 8 is also a rational number, then 0 by 5 divided by 0 by 8 is what? That is a question. So we know what a rational number is. Rational number is any number that can be written in the form of a fraction like this. Now, if your denominator is 0, then it is not a rational number. Your numerator can be 0, but if your denominator is 0, it is not a rational number. So here we can see this is a rational number. This is also a rational number. But what happens when you divide both these numbers? What do you get? You get a rational number is the question. So let's do that division and see. So we have 0 by 5 divided by 0 by 8. This is what is given to us, 0 by 8. Now, how do we do division of rational numbers? We write 0 by 5 into, write the reciprocal, 8 by 0. 0 and then we multiply the numerators and denominators. 0 into 8 is 0, 5 into 0 is 0. So when we have a denominator 0, when something has to be divided by a denominator 0, we don't know what the answer is. It is undefined. This is not a rational number. Okay, so when your denominator is 0, if you have to divide something by 0, the answer is undefined. So that is our answer here, option D. So let's tick that. Option D is our answer. Question 2. A and B are two rational numbers such that A plus B is equal to 0. Then, which of these options is correct? So let's start with the first option. A is equal to B. Okay, so that means let's take one number and see. Let's take A as 2, and if it says A is equal to B, that means B is also 2. So let's try this. So this is A, this is A, and this is B. So both are the same because here according to this option A is equal to B. So we have taken A to be 2 and B to be 2, and let's try this. Now if we do A plus B, that is 2 plus 2, our answer is not 0. 2 plus 2 is 4. So this first option cannot be correct. Now the second option, A and B are numerically equal. That means if A is 3, then B is also 3, numerically equal. Just like option A. So here also if we say A plus B, this is not equal to 0. So here it says it's equal to 0, but we know it's not equal to 0. So this option is also wrong. Option C says A and B are numerically equal but opposite in sign. So that means if A is 2, then B is also 2 but opposite in sign, minus 2. So A is 2 and B is minus 2. Now A plus B, let's see how much it is. 2 plus minus 2, this is A plus B. How much is it? So 2 minus 2 is 0. So this option C is correct. That means A and B are both equal. Numerically they are equal, but they have to be opposite in signs like this. So our correct answer here is option C. Question 3. So what does this question mean? Here it says if we multiply a rational number 3 by 8 and the additive inverse of 3 by 8, which is our answer? So what is the additive inverse of any rational number? It's the same number with the opposite sign. Okay, so the additive inverse of 3 by 8 is minus 3 by 8. This is the additive inverse of 3 by 8. Now we have to find the product. Product means we have to multiply these two. So 3 by 8 into minus 3 by 8. So multiply the numerators. 3 3s are 9 minus 9. 8 8s are 64. So our answer is minus 9 by 64, which is option D, minus 9 by 64. Question 4. The sum of a rational number 2 by 3 and its reciprocal. Sum means you have to add up 2 by 3 and the reciprocal of 2 by 3. So what is the reciprocal of 2 by 3? 2 by 3, the reciprocal will be 3 by 2. Now the sum means we have to add up these two. So 2 by 3 plus 3 by 2. Now here you have to find the LCM of 3 and 2, which is 6. Now get the new numerators. 3 2s are 6, so multiply this also by 2. 2 2s are 4 plus the second one, 2 3s are 6, so we multiply this also by 3. 3 3s are 9. So here what do we have? 4 plus 9 is 13 by 6. Convert this to a mixed number. Divide 13 by 6. 6 2s are 12. What is left? 1 to make it 13 and by 6. So what do we have here? 2 1 by 6. Which is our option here? 2 1 by 6 is option B. So that is our answer. Question 5. The product of two rational numbers is -1. If one of them is 2 by 5, what is the other? So the product means the answer when you multiply two numbers is this. One of them is given to us, we have to find the other. That means when you multiply 2 by 5 with another number, we don't know what that number is. So we're going to consider that to be x. Then the answer is -1. So now we're going to find the value of x. To find the value of x, we write -1 as it is. Now we are going to transpose 2 by 5 to the other side. It becomes division. So it is 2 by 5. So here we write. Now to find the value of x, we say -1 into 5 by 2. So here we have -1 into 5 by 2. So -1 into 5 is -5, and in the denominator we have 2. So what's our answer here? -5 by 2. This is the other number. And which option is that? We have -5 by 2 here. So that is option C. Question 6. Here we have two statements, statement 1 and statement 2. Now we have to see if both the statements are true or both are false, or if one is true and one is false. So that is what we're going to see here. Now statement 1 says, for a rational number 7 by 9, that is, if you take a rational number 7 by 9, now this part, if you subtract a 0 from it, we get 7 by 9. So that's correct. 7 by 9 minus 0 is 7 by 9. You take any rational number there. Now 3 by 8 minus 0 will give you 3 by 8. When you subtract 0 from any number, you get back the same number. But here it says 0 minus 7 by 9 is equal to minus 7 by 9, which is also true. Okay, 0 minus 7 by 9 gives you minus 7 by 9. So here can you see this is working only in one direction. That is, when you put 0 here, you get your answer. You get back the same number. Only then you say it is, this is the identity. 0 is the identity. You can say when you get back the same number. Like in the case of addition. Now suppose I say 3 plus 0, I get 3. If I say 0 plus 3 also, I get 3. So can you see this works in both directions? Here 3 plus 0, when I put 0 here, I get back the same number. When I start with 0 also, I get back the same number. So in the case of addition, I can say 0 is the identity of the number. Or I can say addition has 0 as its identity. Whereas in the case of subtraction, 0 is considered only a right identity because it works only in one direction like this. It doesn't work in the other direction. So we say subtraction has only right identity. So statement 1 is true. Now statement 2 says subtraction has no identity. Now here we saw that subtraction has right identity. Then here why does it say that it has no identity? That's because for a true identity to exist, it must function on both sides, in both directions. It should be a left identity as well as a right identity. Like if I say 3 minus 0 is 3, I'm getting it back if it is a right identity. Now 0 minus 3 is negative 3, minus 3. We are not getting back the same number. Can you see it's different? So subtraction has only right identity. But for it to be a true identity, it should function in both directions, both the right and the left. So we say subtraction has no identity. That means this statement is also true. So both statements are true. So in that case, our answer is option A. So remember, subtraction has only right identity because it works only in one direction. And for it to be a true identity, it should work in both directions. That's why the statement says subtraction has no identity. Question 7. Assertion A says additive inverse of 2 by 5 is minus 5 by 2. Now, what is an additive inverse? The negative of any rational number is called as additive inverse. In this case, 2 by 5 is the rational number, isn't it? So, what is the negative of 2 by 5? Minus 2 by 5. So, the additive inverse of 2 by 5 is minus 2 by 5. And what is an additive inverse? When you add up a rational number and its additive inverse, your answer should be 0. Now, if you take 2 by 5 plus the negative 2 by 5, when you add up these, what do you get? Whenever you add up a positive number and its negative number, your answer is 0. So, from this you understand that the additive inverse of 2 by 5 is negative 2 by 5. But in this case, what are they telling us? The additive inverse of 2 by 5 is negative 5 by 2. This statement is false. So assertion A is false. And let's see what the explanation given to us is. The reason is for every non-zero rational number A, that is in case you take 2 by 5 in place of negative A, that is negative 2 by 5 is such that when you take the rational number and add its negative number, your answer is 0. So this reason is correct, but the assertion is false. This is false and this is true. So assertion A is false and the reason is true. Now which option is that? Option D, which says A is false but R is true. So this is our correct answer. Question 8. Assertion A. What does it state? It states that the multiplicative inverse of negative 7 by 5 is negative 5 by 7. What is the multiplicative inverse of any rational number? The reciprocal of that number. Okay, so negative 7 by 5, the reciprocal of that is negative 5 by 7. That means this statement is true. And we also know that when you take a rational number that is negative 7 by 5, when you multiply it by its multiplicative inverse, in this case negative 5 by 7, that is the reciprocal. Now see what answer you get. We can cancel the 7s, it's just 1. You can cancel the 5, 5 ones are 5, 5 ones are 5. When you multiply the numbers, you just get 1. And now we're going to multiply the signs. Minus into minus is plus. So your answer is positive plus 1. Your answer is just 1. So what did we do here? We took a rational number, multiplied it by its multiplicative inverse and we got the answer as 1. Then you know when you get your answer as 1, you know that this is the multiplicative inverse of this rational number. So the first statement is true. The assertion is true. Now let's see if the reason is the correct explanation for this. For every non-zero rational number A, now in this case say negative 7 by 5. It's a non-zero rational number. There is a rational number 1 by A. So 1 by A is the reciprocal of A. So that's true, isn't it? You have a number, you have its reciprocal. And here what does it say? When you multiply that number and its reciprocal, your answer will always be 1. And we have proved it here. The answer is 1. That means this reasoning is correct. And it's a correct explanation for the assertion. So which option is our answer? Our answer is option A. That is the first one. Both the assertion and the reason are correct. And the reason is the correct explanation for the assertion. So this is a correct answer. Question 9. Assertion A states 1 by 2 plus 2 is equal to 5 by 2 and 5 by 2 is a rational number. Now here let's add it up first of all and see. So 1 by 2 plus 2. So this will be 2 by 1. Our LCM will be 2. So here it is 2 into 1. So 1 into 1. 1 ones are 1 plus When you go to the other side, it is 1 into 2 is 2. So 2 into 2 is 4. So 1 plus 4, which is 5 by 2. So here the answer 5 by 2 is correct, and here it says which is a rational number. Now any number is said to be rational if it can be written in the form of a fraction where both the numerator and the denominator are integers. Now 5 by 2 is in the form of a fraction and 5 and 2 are integers. So assertion A, this statement is true. So we can say this statement is true. So now let's look at the reasoning here. Here it states if P by Q and R by S are any two rational numbers, then P by Q plus R by S is equal to R by S plus P by Q. Now we know the commutative property of addition, that is, when two numbers are added together, then even if you change their positions or change their order, their sum, their answer will not change. That is, if you take the example of the first one itself, now here we found 1 by 2 plus 2, I can say 2 by 1 is equal to 5 by 2. Now let me change this order. If I say 2 by 1 plus 1 by 2, my answer will still be 5 by 2. So this is the commutative property of addition, and this statement is also true. This statement is also true, but is this the correct explanation for the assertion? It is not. This is a commutative property, and we are not talking about the commutative property here. We're just saying when you add up two rational numbers, you get an answer which is also a rational number. So both the statements are correct, but the reason is not the correct explanation for the assertion. So which is our correct option here? Look at option 2. It says both A and R are correct, but R is not the correct explanation for A. So our answer that we're going to choose is option B, where both are correct, but R is not the correct explanation for A. Question 10. Assertion A states 0 and 11 by 12 are two rational numbers. Okay. So 0 is a rational number, 11 by 12 is also a rational number, and 11 by 12 is not equal to 0. So 11 by 12, when you divide it, it's not equal to 0. They are two rational numbers. Then when you divide 0 by a rational number which is not equal to 0, so divide 0 by a non-zero rational number, then your answer will always be 0, which is a rational number. Now this is true, isn't it? When you divide 0 by any non-zero rational number, non-zero rational number, in this case the non-zero rational number is 11 by 12, your answer will be 0. So, and 0 is a rational number because we can write 0 as 0 by 1. Any number that can be written in the form of a fraction is called a rational number. We can write 0 as a fraction. We can say 0 by 1. So this statement is true because it says the answer that you get is a rational number. So assertion is true. Now let's listen and see what reason has to say. Now, according to this reason, if a rational number, like in this case 0 is a rational number, is divided by some non-zero rational number, that is 11 by 2 by 12, it's not equal to 0. That means it is a non-zero rational number. The result is always a rational number. What is the result here? 0, and that is a rational number. So this statement is true. That means the reason is true and it is the correct explanation for the assertion. So which is our answer? Our answer is option A, that is 1. Both A and R are correct, and R is the correct explanation for A. Question 2. The rational number that does not have a reciprocal. We have to write the answers to all these. Which is the rational number that does not have a reciprocal? Now you take any rational number, 2. Suppose you take a rational number 2. To make it a rational number, we give it a denominator 1. What is the reciprocal of this? 1 by 2. Now which is the rational number that does not have a reciprocal? The rational number 0. Now 0 is also a rational number. Now this does not have a reciprocal. Okay. So what is the answer here? 0 is the rational number that does not have a reciprocal. Question 2. We have to write the rational numbers that are equal to their reciprocals. Which are the rational numbers that are equal to their reciprocals? Now, suppose I take a rational number 3. So this becomes 3 by 1. What is the reciprocal? 1 by 3. So they are not equal, isn't it? They are not equal. Now the question is, you have to find rational numbers that are equal to their reciprocals. Now if I take 5 by 7, what is the reciprocal of this? 7 by 5. They are not equal. So which one will have their numbers equal, their reciprocals equal? Now what about the number 1? Now I can write 1 by 1. What is the reciprocal of 1 by 1? It's 1 by 1. So they are equal, isn't it? They're equal to each other. So the number 1 is equal to its reciprocal. So that is our first answer, 1. Now there's one more number. Now take minus 1. Minus 1, I'll make it a fraction by writing 1 by 1. What's the reciprocal of this? 1 by minus 1, which is also equal to minus 1 by 1. Now whenever you have a minus sign like this, you can put it in the numerator or you can even put it in between both. It's the same. So minus 1, the reciprocal is equal to its number itself. So both these are rational numbers that are equal to their reciprocals. So let's write the answer, minus 1. So let's read the question again. The rational numbers that are equal to their reciprocals are 1 and minus 1. Now we have to write the reciprocal of minus 8 by 17 plus minus 8 by 17. So let's work this out. Minus 8 by 17 plus minus 8 by 17, isn't it? So this becomes, since the denominators are the same, that is our LCM. So minus 8 minus 8, because plus into minus is minus. Now this becomes minus, since the signs are the same, put the same sign and add 8 plus 8 is 16. So we've got minus 16 by 17. Now the question is, we have to write the reciprocal of this number. So minus 16 by 17, the reciprocal is 17 by minus 16. Or we can write this as minus 17 by 16. Or we can put that minus sign in the middle and write 17 by 16. All these will be the same. So let's write minus 17 by 16. This is our answer. Question 3. Write 5 rational numbers between minus 3 by 2 and 5 by 3. First thing we do is we find the LCM of the denominators 2 and 3, and the LCM is 6. So we take the first rational number minus 3 by 2. Here we have to change the denominator to 6 now. So we multiply 2 by 3. So we multiply this also by 3. So what do we get here? 3 3s are 9 and 2 3s are 6. Take the second rational number 5 by 3. Here also the denominator has to become 6. So multiply 3 by 2 and 5 by 2. So now 5 2s are 10 and 3 2s are 6. So what we have now? We have two rational numbers, minus 9 by 6 and 10 by 6. Now here, since there's a big gap between minus 9 and 10, this is a negative number, this is a positive number. Imagine a number line and imagine where minus 9 will be and where 10 will be. There are many numbers between minus 9 and 10, isn't it? So in this case, you just have to pick out any 5 numbers between minus 9 and 10 on the number line and write it as your 5 rational numbers. So let's take the number after, the one that comes just before minus 9, that is minus 8. So that becomes minus 8 by 6. Then I can take the one before that, minus 7 by 6. Then minus 6 by 6. Minus 5 by 6. Minus 4 by 6. So I've got 5 rational numbers. Now there are many more rational numbers that I can get. Since there's a gap here between minus 9 and 10, I've picked out these 5 rational numbers. Then the next thing we can do is reduce all this to the lowest term. So we have minus 8 by 6. We can divide both by 2. 2 4s are 8, 2 3s are 6. Now let's see the others. Minus 7 by 6 we can't do. Let's go to the next one. Minus 6 by 6. Now 6 1s are 6, 6 1s are 6. Now the next one, minus 5 by 6 we can't do. Let's go to the next one, minus 4 by 6. So that will be, we can divide both by 2. That is 2 2s are 4 and 2 3s are 6. So what do we get as a final answer? Here we get minus 4 by 3. Then we have minus 7 by 6. Then we have minus 1. 1 by 1 is 1. Minus 1. Minus 5 by 6. And minus 2 by 3. So this will be a final answer. Question 4. Write 5 rational numbers greater than -4. Okay, so all numbers that come to the right of -4 on a number line. Now let's take a number line like this. So we have a number line, we have -4 here. All the numbers to the right of -4 are greater than that. So all the numbers to the right, as you continue, you can fill this in with more numbers, you can fill this in with more numbers. But numbers to the right of -4 are all greater. That means there are many rational numbers greater than -4. I will just take a few of these and write that as our answer. So what will our answer be? We can say -3, -2, then I can say 2, I can say 4, I can say 5. Any of these numbers, I can take 5 rational numbers that are greater than -4, they are on the right of -4. Question 5. What should be added to -2 1 by 2 to get -3 1 by 3? That means if we take -2 1 by 2, what should we add to this? So let's consider that unknown number to be x. So if we add up x to this -2 1 by 2, we get -3 1 by 3. Now we have to find the value of x. So first let's convert this. So 2 2s are 4 plus 1 is 5. So this becomes -5 by 2 plus x is equal to, convert, the sign is minus, 3 3s are 9 plus 1 is 10 by 3. Now to find the value of x, we leave x here on the left hand side. On the right, we already have minus 10 by 3. Now here we have minus 5 by 2. Now we are going to move minus 5 by 2 to the other side because it is plus. It's going to change to minus when it goes to the other side. So minus 5 by 2. Now we write this as x is equal to minus 10 by 3. Now let's remove the brackets. So minus into minus is plus. So that becomes plus 5 by 2. So now as you can see, x is equal to minus 10 by 3 plus 5 by 2. We have to find the LCM of the denominators 3 and 2. And the LCM of the denominators 3 and 2 will be 3 2s are 6. So we're going to use that as the common denominator. Look at the first rational number, minus 10 by 3. Denominators 3, 3 2s are 6. So multiply 10 also by 2. 10 2s are 20 and that is minus 20. Plus the second denominator is 2, 2 3s are 6. So we multiply this also, 5 3s are 15. So this becomes 15 here. So now what do we have? Let's continue by writing x is equal to minus 20 plus 15. Signs are different, so put the sign to the bigger number and subtract. 20 minus 15 is 5 by 6. So now we have our answer. So the answer is minus 5 by 6. What was the question? The question is, what should be added to this number to get this, isn't it? So the number to be added is minus 5 by 6. You can also check your answer and see in the place of x, if you write this and add it with this, you must get this answer which is given in the question. Question 6. What should be subtracted from 2 1 by 2 to get minus 3 1 by 3? So whenever you have from a number for subtraction, that number should be written first. So this is how we're going to write this. We're going to say what should be subtracted from 2 1 by 2, isn't it? 2 1 by 2 minus that unknown number, we'll call it x, and the answer is minus 3 1 by 3. So first thing, let's convert this. 2 into 2 is 4. 4 plus 1 is 5. 5 by 2 minus x is equal to 3 3s are 9 plus 1 10. Minus 10 by 3. Now, just to make our work easier, we're going to move this x to the other side. So minus x will become plus x, and we'll move this minus 10 by 3 to this side. So this will become 5 by 2 minus 10 by 3 becomes plus 10 by 3, and this is equal to x. And now I'm just interchanging the sides. I'm keeping x on the left hand side, and on the right I'm having the same numbers, 5 by 2 plus 10 by 3. Now let's work this out. X is equal to, now here find the LCM of 2 and 3, which is 6. First denominator is 2, 2 3s are 6, so multiply 5 also by 3. 5 3s are 15. Plus, let's go to the next one. 3 2s are 6 here. So we multiply 10 also by 2. 10 2s are 20. So now what do we have? X is equal to 15 plus 20, which is 35 by 6. Now let's convert this. 35 by 6. 6 5s are 30 and there is 5 left by 6. So what is our answer? What should be subtracted? The question is given there. What should be subtracted? The answer is 5. 5 by 6 should be subtracted from the other rational number to get minus 3 1 by 3. So this is our answer. Question 7. If m is equal to minus 7 by 9 and n is equal to 5 by 6, we have to verify this. That means we have to say that m minus n is not equal to n minus m. So we're going to substitute m and n with these values. So m minus n. So that will be m is minus 7 by 9 minus n is 5 by 6. And they say this is not equal to n minus m. N is 5 by 6 minus m is minus 7 by 9. So we've got this here. Now we have this as the left hand side. This is the left hand side and this is the right hand side. So first let's work out the left hand side. So this is the left hand side. Let's work this out and see. Now here, as you can see, denominators are different, so we must find the LCM of 9 and 6. So let's do that. The LCM of 9 and 6. 3 3s are 9, 3 2s are 6. Continue with 3. 3 1s are 3. Bring down 2. Now continue with 2. 1 and 1. So what is our LCM? Our LCM is 3 into 3 into 2. 3 3s are 9, 9 2s are 18. Our LCM is 18. So here let's use that. LCM is 18. Take the first rational number. 9 into 2 is 18. So minus 7 into 2 is minus 14. Minus, take the next rational number. 6 3s are 18. 5 3s are 15. So that is 15 here. So we'll continue. Minus 14 minus 15. Signs are the same. So put the same sign and add. 14 plus 15 is 29 by 18. So on the left hand side we have 29 by 18. Now let's look at the right hand side and work this out here. So here 5 minus 7 by 9. We can multiply this. Minus into minus is plus. So the right hand side. So we are working out the right hand side now. So we are looking at the two rational numbers given here, this one and this. So let's write this now again. So that becomes 5 by 6 minus into minus is plus. So plus 7 by 9. So here also we find the LCM of 6 and 9, which we have already found here. We found it to be 18. So let's use that 18. Look at the first denominator, multiply this by 3 to get 18. So 5 into 3 is 15. So here we have 15 plus 9 into 2 is 18. So multiply 7 into 2. 7 2s are 14. So now let's add up both these. 15 plus 14 is 29 by 18. So here what do we have? Here on the left hand side we have minus 29 by 18. On the right we have 29 by 18, and we know that the left hand side, as you can see, is not equal to the right hand side. So we have verified left hand side is not equal to the right hand side, hence verified. Question 7. It's the same question. Under that, the second part, minus in brackets m plus n is equal to in brackets minus m plus minus n in brackets. So we're going to substitute values and we have to verify that both the left hand side and the right hand side are equal. So here let's substitute the values for m and n here. So this will be minus, in brackets we have m, which is minus 7 by 9 plus n, which is 5 by 6. So this is what we have on the left hand side, and the statement says that this is equal to what is on the right hand side. So what do we have on the right hand side? Minus m. Minus m means minus of m, and m is already minus 7 by 9. That is minus 7 by 9 plus minus n. And how much is that? Minus n is 5 by 6. So first we're going to work out what is on the left hand side. So left hand side is this. We're going to work this out and get an answer first. So let's begin by doing what is on the left hand side. So left hand side, LS just means left hand side. So here now we have minus 7 by 9 plus 5 by 6. To work this out, we have to find the LCM of 9 and 6. So let's find the LCM of 9 and 6. Now 3 3s are 9, 3 2s are 6, then 3 1s are 3 and bring down 2, 2, 1 and 1. So our LCM is 3 into 3 into 2. 3 3s are 9, 9 2s are 18. So we have 18 here as the LCM. So let's work that out. So the minus remains there outside the brackets. Here we have 18 and let's see the new numerators that we are going to get. So take the first rational number minus 7 by 9. 9 into 2 is 18. So multiply 7 also by 2. 7 2s are 14. So that is minus 14 plus. Now here we have 6, isn't it? 6 3s are 18, so multiply 5 also by 3. 5 3s are 15. So now let's work this out. So this will be minus into, in brackets we have minus 14 plus 15, signs are different. So we put the sign of the bigger number and subtract. So that is plus 15 minus 14 is 1, 1 by 18. Now when we open the bracket, we have to see the sign before the bracket, it's minus. So minus into plus will be minus. So here our answer on the left hand side is minus 1 by 18. So let's see that now what we get on the right hand side. So now on the right hand side we're going to work this out. So right hand side we have minus, in brackets we have minus 7 by 9 plus minus 5 by 6. So let's remove all the brackets first. So here we have minus into minus, so this becomes plus. So this is plus 7 by 9. Now here we have plus into minus, which is minus, minus 5 by 6. Now we have to find the LCM of the denominators 9 and 6, which we have already found here. LCM of 9 and 6 is 18. So let's use that. So this is going to be 18. Now look at the first rational number. It's 7 by 9. Let's multiply this by 2. 9 2s are 18. So 7 2s are 14. So here we have 14 minus, the next one is 6 3s are 18. So multiply 5 also by 3. 5 3s are 15. So now we have 14 minus 15. We put the sign of the bigger number. And what is the sign of the bigger number? Minus, and subtract. 15 minus 14 is 1 and the denominator is 18. So look at the left hand side. Left hand side we have minus 1 by 18 and right hand side also we have minus 1 by 18. That means left hand side is equal to the right hand side and we have verified it. So let's write that left hand side is equal to right hand side, hence verified. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.